Hello dear students, welcome to this course on lasers and fiber optics. The subject code is SPT205. It is meant for BSc non-medical students. My name is Dr. Rajesh Sharma. First of all, I would like to introduce briefly myself. So, I did my PhD from DRDO Jodhpur and Punjab University Patiala, and then I have worked as Dean and Head of the Department in AICT affiliated institutes for about 5 years, and then I went to abroad. In Germany I have spent about 5 years and 3 years in United States. This College of Optics and Photonics is world number 1 institute in the optics and photonics. So I would be your instructor for this course. Let's have a detailed look at the course which we are going to do. And I hope that this course would be very interesting for the students as far as the details are concerned. And I would say that the essential systems of the lasers that could be understood with the help of this course. Let's come to the course objectives. So we have our main goal would be to create a platform for the students where they can learn the techniques which are useful for the industry and different type of the applications and which can generate jobs. That is also our concern. And let's come to the course outcomes. We have the first unit or the course outcomes in the first unit. These will be like basically to introduce the absorption and stimulated emission and fundamentals of the lasers. And after that, we would like to come to the second point, that we would like to understand in detail that how does a laser work and how in the end of this course the students would be having enough expertise to learn and analyze the things which are related to the fundamentals of the lasers. And yeah, this stuff is also available online. I would not like to go into the details of this. Let's come to the syllabus of the lasers and fiber optics. So unit 1, so we have divided this into the 3 categories. So you have the fundamentals of the lasers. These fundamentals of the lasers means that we would be able to differentiate that what is essential difference between the conventional source of the light and the laser source of light. So that we would like to understand here. And after that, okay, how does a laser work? So that would be our concern in this case. So what we would like to do, that we would like to understand that how a laser works and what are the different principles and how much is the broadening in this case. So if you look into the details, so what you would have in this section, we would have this portion where we have all the details related to the fundamentals here. So if you look into, then you have all the details in this case, and here you would have the mechanism of the lasers. Okay, I hope that this would be helpful. And in the second unit, what we will do, that you would have different type of the lasers, variety of the lasers are to be studied in this case, and these lasers, we need to understand that why and how these lasers they work and what are the essential requirements which makes these lasers very important for us. That thing we would like to understand on top in this case. After that, we would like to come to the next section, which is the unit 3. And in unit 3, so how we can apply the knowledge of the lasers to the fiber optics, and then we would have dispersion losses and different type of the optical fiber losses in this case. So welcome to this first lecture. Now I would like to come to the actual content of this stuff. So we would have the fundamentals of the laser, difference between the conventional source and laser source, absorption and emission of the radiations, main features of a laser and references. We will also work out some problems which are helpful for the students. So let's come to the other point, that what we are trying to understand in this case. So let me pull out one thing, that if you would like to understand the lasers, then first of all we need to understand that why the lasers are required. Okay, so let's try to understand that how a laser light is different than the conventional source of the light. Okay, so let's see that, okay, in terms of the intensity, you would have higher intensity. So you have, let's say that, okay, what you are trying to do, you have a lens, optical lens. You would like to focus the light with the help of the optical lens. No? So what you can do, you can focus at this point, okay, here in this case. In one of the fundamental examples of these lasers, I would say that here you have the conventional light source. Simply sunlight you can use, no? Sunlight. So what will happen in case of the sunlight, that what we are trying to do, we have this light which is coming from sun, and this light will be focused with the help of a lens onto a focus point here. No? And we will see sometime, if you might have noticed in your childhood, that many times the people, they used to ignite the cigarettes with the help of this focus light. Although that is not a good example, but you can put a piece of paper in front of the laser and you can burn that. Okay, same thing you can also do with the help of the sunlight when you focus that with the help of a lens, and that focus light, although it will not deposit as much energy as that of the lasers, but of course it will be helpful to burn the piece of the sample, which is a piece of paper. On the other hand, if you have the laser light, okay, now in case of the laser light, you have quite intense results, and what you would have highly intense light which will be incident on the sample, and this light which is highly intense, that can be applied for various type of applications. So our idea would be to study that what is the essential difference between the conventional source of light and the laser light. And if we would like to understand that, then we have to also study that what are the three processes which we need to understand in this case. No? So let's come to the next point, which is there. No? So we need to understand three processes mainly. The first process is the induced absorption. So let me write that, pull up a new window for the board. Okay, so here you have this one. So what we have, that there are three processes. I would like to highlight these three processes. This is number one step, this is the second step, okay, and then you have the third step here. No? So in the case of the first one, we will say that let's say if you have an atom in the ground state, then these atoms they can absorb energy, and the atom will be excited to the level 2. No? This is level 1, this is level 2. You know, this process, when the atoms they absorb energy, then what will happen? The atoms from the ground state, they are excited to the excited state. Okay? So this process is called induced absorption. No? This process is called induced. Okay, I would like to write that. No? Induced absorption. So now the second point which is there, okay, so you would have the spontaneous emission. So what you would have? You would have spontaneous spontaneous emission. I would like to write that. So the third would be the induced emission. So third process that is there. Okay, so it would be induced emission. So let's try to understand these three processes, what will happen in this case, and how these three processes are important in case of the lasers. So that we need to understand. No? So that we have to understand in this case. So if you look at the first process, what you will do, that you would like to shine a photon of energy at nu, and this energy, how much energy is required, that is also a question. So energy which is required, that should be a difference between these two energy levels, E2 minus E1. Let's say that, okay, how much energy is required, so it should be equal to E2 minus E1. This is the energy which is required in this case. So this energy which is there, so this energy will be able to absorb by the material, and the atoms will be excited from the ground state to the excited state in this case. So what will happen? The outcome is nothing, it is absorption process. In the second case, now you would have the atoms which are in the excited state, and these atoms will not stay for longer time in the excited state, and then they will emit the photon. This process is called the spontaneous emission. And then there is another probability that the excited state electron, if you force these the atoms to come to the ground state with the help of a photon which is shined in this case, in that case you would have the two photons. One photon which is the parent photon in this case, and the second photon is the photon which is resulted as the de-excitation takes place from the excited state to the ground state. So it is, I mean that, okay, it would be initially difficult to understand that how does the atoms are excited, but it's very simple. If you take an example, we have to understand first of all that what is the difference between the excitation of the atom. Sometimes we confuse that if the electrons are excited or the atoms are excited. So if I pinch, let's say that this is my hand, I would like to pinch it with the help of my other hand, and what will happen in that case? The pain goes to entire body. So what does that mean? That it is not the portion, this is not only this portion which is giving us pain, but it is felt all over the body. Similar condition is that if you have atoms, in case of the atom, what will happen? You would have, let's say that so you have the orbits, no? You have the orbits in case of the atoms. So you have a positively charged nucleus, okay, and then this positively charged nucleus, that will be, okay, here. Now the electrons, they are revolving around the nucleus, no? Okay, so that we have to understand from here, no? You have electrons which are revolving around the nucleus, and here you have another one which is, let's say that if I draw like this, then you have other electrons in this case. So you would have these type of the electron 2, 8, okay, K shell and L shell. So now, for example, if what I'm doing, that if I'm just disturbing this electron, in that case what will happen? The entire atom, for example, if I knock out this electron out of the atom, the entire atom, that will go into the excited state. So it is, okay, so my entire body is paining if the electron and atom would have same feeling. If you detach an electron from an atom, it will go into the excited state. Unless and until it comes to the ground state, it will not feel comfortable. Okay, so comfort energy is the energy which is at the ground state. So that we have to discuss. What will happen in this case? The spontaneous emission means that it is automatic healing process. So, for example, if we would like to take an example of simply that, I will say that some of the students, can they go and sit on the fan? No, 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 we are not able to sit on the fan. Why we are not able to sit on the fan? Because we don't feel comfortable on the ceiling fan. We are comfortable when we are sitting on the chair, or we are sitting on bed. So that is the state of minimum energy in this case. What will happen? Let's say that if some student takes a challenge, oh no, no, I would like to, sir has said that let's climb on the uh, fan. So he will climb, but the lifetime of the student who climbs onto the fan, that will be very short. A student will say, oh no, no, I can show my tricks, but it's very difficult. Let's come to the ground state. Okay, so lifetime of the atoms in the excited state will be very small. So it would be of the order of 10 raised power minus 8 seconds. So what will happen here? Okay, what we are trying to do, that the atoms which are coming directly to the ground state, they will emit the photons, and the photon energy will be equal to the difference between the two energy states in this case. And finally, in the third case, what will happen? We would like to stimulate, we would like to force this electron to atom to come to the ground state. And what will happen in this case? These two photons, they will be called, they will be in phase photons in this case. What will happen if their phases will be same? So what we have learned with the help of this slide, that is very important thing. If you, in the nutshell, we learned that what is the induced absorption, we learned what is spontaneous emission, we learned what is induced emission, and we should not also be sometimes there are different names and we confuse them. In some books it will be written stimulated absorption. So we should not, the word, like if you are watching this word stimulated, this word and this word, these two words, they are same. So stimulated absorption, some people say stimulated emission in this case. No, so we should not worry about that. No? So that is the thing which we would like to highlight in this case, to understand in a better way that what we are talking about. Okay, so second thing is that it is not possible to have the emission. Okay, so let's pull up the slide, what we were saying. With the help of this slide, we tell that, okay, why do we need to study lasers? Because everywhere you have lasers. In your life, day-to-day life, you will see that you would have lasers. So you would have lasers everywhere. And everywhere means that, okay, what we are talking about? So you would have the laser stuff everywhere, wherever you go. So we have to understand from that point of view. So you have why we are requiring laser. Lasers have a lot of applications in many fields, and these fields can range from simple household things, when the children they play with the toys at their home, and what they say that you would have, okay, so you would have toys, industry, medical application. There are a lot of applications of these lasers, okay, in our life. No? And then we would like to come to the properties, and here you have advanced applications, and here are the processes which I was talking about. And let's come to the special properties of the laser light. Okay, so let's talk about the first property is monochromaticity, unidirectional, highly intense, narrow bandwidth, coherence. These are the properties which are there. So if you come to the details, if you would like to understand this, so the first is that first property of the laser which is making it different from the conventional source is monochromatic. Okay, so it would be monochromatic. So monochromatic, what is the meaning of monochromatic? So it means that you have mono means single and chromatic means color. So the light which is composed of single color is known as the monochromatic light. But in principle, it is difficult to say that due to the physical principle which we would like to understand, that it is difficult to understand that, okay, it would be difficult to tell that if it is the monochromatic light. So what we use the word highly. We use the word highly, okay, in this case. And the second thing which we would like to tell here in this case, this is highly intense, no, highly intense. The laser light is highly intense. So maybe in some book you would have different properties given, but they are more or less, they are in the subset of these three categories or four categories which we would like to highlight. Then you would have coherent, coherent, and then coherent, and then you would have the last one is the required, which is the monochromatic, highly intense, and coherent, and then you have unidirectional. Unidirectional. The intensity of the conventional source of light is small, no? So this means single color. Highly intense mean that what will happen? The excited state which you are talking about, from excited state when atom comes to the ground state, so you would have these photons, they will what they will do, they will simply be added up, their phases will be added up and they will end up in the highly intense source. Coherent means that, okay, all the emitted photons are coherent, okay, they are in phase. And unidirectional means that how much is the target of the direction. So at long distances you will see that there is no divergence of the laser light, okay? So that we have discussed in this case. So questions. So why lasers are uniquely hazardous? I would leave these questions as a small exercise to you guys so that you can do and try to understand that what is the meaning of the laser, and the references are, these are the references which we would like to have in this case, no? So you can have internet sources, books, everything, and this information is given in the laser. So what is overall aim? If you look into the today's lecture, we are able to learn about the fundamentals. What is the difference between the fundamentals and conventional source of the light and the laser source, and absorption and emission, and what are the main features, and then we have discussed the other features. In the next lecture, we would like to come to the depth of the understanding and various applications of the lasers. I hope that this lecture would be helpful. Thank you.